Problem number 9. Find the binomial expansion of 1 plus x to the whole 5 using the second factorial method. According to the second factorial method, a plus b to the whole n equals to this expression. It is the second factorial method. Look, a plus b to the whole n equals to this expression on the right side according to the second factorial method. We have already learned about the second factorial method, so I don't want to go in depth. Since it involves 0 factorial, for the 0 factorial we're going to put 1. So according to this second factorial method, our given binomial expression is 1 plus x to the whole 5. According to the second factorial method, it equals to 5 factorial over 0 factorial into 5 minus 0 factorial times 1 to the 5 times x to the 0 plus 5 factorial over 1 factorial into 5 minus 1 factorial times 1 to the 5 minus 1 into x to the 1 plus 5 factorial over 2 factorial into 5 minus 2 factorial times 1 to the 5 minus 2 times x to the 2 plus 5 factorial over 3 factorial into 5 minus 3 factorial times 1 to the 5 minus 3 times x to the 3 plus 5 factorial over 4 factorial into 5 minus 4 factorial times 1 to the 5 minus 4 times x to the 4 plus 5 factorial over 5 factorial into 5 minus 5 factorial times 1 to the 5 minus 5 times x to the 5. Look, my n is 5. So put 5 all the way for all the yellow n's, because n is 5 in this case. We know that the rest of the thing is the same. For term a, which is my 1, we're going to start with the maximum power, which is 5. So we have 1 to the 5, and then it decreases by 1. It is in descending order on the right side. 1 to the 5 minus 1, and then 5 minus 2, and then 5 minus 3, and then 5 minus 4, and then 5 minus 5. So the time when you get 5 minus 5, which means that the power of 1 is 0 in this case, which is my a. So the time when you get the power 0 for the first term, you have to stop the process. We're going to stop the process. This is the one indication. The second indication is that if this n, this yellow n, equals to the r, remember this is my r, this is my r, 3, 4, 5, 2, 1, this is my r. So if n equals to r, like we have it here, 5 and 5, then we have to stop the process. We know that 0 factorial equals to 1. To further simplification, you will get this expression on the right side. 0 factorial is not 0. 0 factorial is 1. It equals to 1 according to the factorial rule. So for the first term, we have 5 factorial in the numerator, which is 5 times 4 times 3 times 2 times 1. And then in the denominator, 0 factorial is 1. 5 minus 0 is 5. So I'm going to have 5 factorial, which is 5 times 4 times 3 times 2 times 1. Similarly, for the second term, we have 5 factorial, which is 5 times 4 times 3 times 2 times 1. 1 factorial is 1, and 5 minus 1 is 4. So we have 4 factorial, which is 4 times 3 times 2 times 1. We have it all the way until at the stage where 5 factorial equals to 5 factorial, which means that n equals to n. Look, 5 factorial is 5 times 4 times 3 times 2 times 1, and 5 factorial is also 5 times 4 times 3 times 2 times 1. 5 minus 5 is 0. 0 factorial is 1. It equals to 1 times 1 to the 5 times x to the 0 plus 5 times 1 to the 4 times x to the 1 plus 10 times 1 to the 3 times x to the 2 plus 10 times 1 to the 2 times x to the 3 plus 5 times 1 to the 1 times x to the 4 plus 1 times 1 to the 0 times x to the 5, which implies that 1 plus x to the whole 5 equals to 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4 plus 5x to the 5. You do simplification here because look, 1 to the 5 is 1, so 1 times 1 is 1, 1 times x to the 0, x to the 0 is 1, 1 to the 5 is 1, so 1 times 1 times 1 is 1. Similarly, x to the 1 is x, 1 to the 4 is 1, so we have 5 times 1 times x, which is 5x, and so on. There we got the final binomial expansion. It is the final binomial expansion for 1 plus x to the whole 5 using second factorial method.